Hey class, this is Mr. Roberts. Nice to see you. Hopefully, I'll see some of you during office hours. I can talk with you, discuss some of the things we're talking about here, and other assignments that we might have going forward. We did start Picture Lab in class last week, and I think we made it through activity 3 or 4. And I'm going to pause that just a little bit and do a little bit of an introduction to 2D arrays in Java. And I'll give you kind of an introductory presentation regarding what they are, how we set them up, and some ways that we can manipulate them. And then we'll be looking at some things in Runestone as well. So I have a empty, actually this is actually the Picture Lab class. In the Picture Lab project, I added a new class called 2, capital TWO, and then D, and then array intro, 2D array intro. And I'm going to open this up. I took everything out of it, all the standard things, and I just gave this a brief description. This program is used to introduce 2D arrays in class. And it's me, and it's March 2020. So let's go ahead and, this is not going to be a complicated project with multiple classes. This is just going to be a single main method. So let's go ahead and make our main method here. So public static void main an array of string objects called args, and we are into main. And a couple things we're going to do in here is, so first of all, let's say that we would like to create a two-dimensional array of something as simple as ints. So basically, when we created one-dimensional arrays before, it looked like this, right? It would be an array of ints, and then we would give it a name, and we would give its dimensions. Well, if you want to create a two-dimensional array of ints, it's just we're going to put two sets of these brackets. Then we give it an array. I'll call this grid 1. And this is going to be a new array of ints. And this is going to be 3 and 2. Let's do 3 by 3. In Java, on the AP subset, AP kind of conventions for the exam, we typically think of things as what's called row major order, and you'll see what that looks like and what that means more as we progress. But because we're in row major order, this first number, if you're going to visualize an array, this would be how many rows we have, and this would be how many columns. So this array is a square. It's got 3 rows, 3 columns. And by default, because this ints is a primitive type, right? These are all initialized to those values that you would expect for a primitive. So these are all going to be values of 0. So I've got 3 rows, and each of those rows have 0, 0, 0, 0, 0, 0, 0, 0, 0. We're going to create another array, just for illustrative purposes, another 2D array. I'm going to call this grid 2. And you can also go ahead and declare these explicitly like this. So I could say it's going to have a 1, 2, and a 3, and a 4, 5, and 6, and a 7, 8, and 9. And because I'm thinking in terms of row major order, what we've done here is we've set up our first row is going to have the values 1, 2, 3. The second value 4, 5, 6. Whoops, I've got an extra comma there I don't need. 4, 5, 6, and then the third row would be 7, 8, and 9. And you can see our columns. If we were looking at the columns, this would be a 1, and below that would be the number 4, and below that would be the number 7. So I've got 3 rows, and these are the column values in each row. So the first row has a column of 1, 2, and 3. Another thing to remember is that just like everything that we've done this year, these start with zero-based counting. So this is row 0, this is row 1, and this is row 2. If I was to call dot length on this grid, it would give me 3, 1, 2, 3, because there are 3 separate arrays inside of it. And another thing is if I was to say grid 2 at 0 dot length, it would tell me that that would have 3 elements. So when you do a dot length on just the name itself, it tells you how many arrays are tucked inside of that array. And then when you do dot length on one of them, it tells you how many elements are in this one. And I could do grid at 0 dot length, or I could do grid at 1 dot length, or I could do grid at 2 dot length, and they would all be 3 because they're 3 long. Generally, we do not see something called jagged arrays. Those are arrays where, let's say like the first row had 3, the next row had, I could say the next row has 4 values, and the row after that has 3 values. We do not deal with jagged arrays in this course. Our arrays are always assumed to be same number of rows, same number of columns. And well, I don't mean that it has to be a square array, but if you've got, for example, 5 rows, every single one of those rows would have like the same number of column values. So now that we've got this here, I think what we want to be able to do is figure out a way so that we can visualize the array. So I'm going to suggest we create a method that will just allow us to print out what this looks like. And because we're not creating, a class, this is just going to be this one project with the main method. Any of the things we do in here have to be static methods. That's not a word that we typically tuck in when we're writing classes in our class, but let's go ahead and do that anyway. So we're going to do a public. This will be a static method, meaning it's not part of an instantiated class. This is not going to return anything. It's just going to be a void, and I'm going to call this show grid. Grid. That would be fine. And what show grid is going to do is it's going to take a 2-dimensional array as an argument, and we'll call that to show. So it's the grid that we're supposed to show. Okay, so close it. So we're inside of here now. So if I want to show this grid that's being passed down here, what we typically have to do is we have to create a nested for loop. The outer loop is going to take care of the rows. So the outer loop is going to look at, so my outer loop is going to look at this, this, and then this. The inner loop is going to look at each one of the column values one at a time, and then it jumps to the next row, and then these columns, and then the next row, these columns. So in row major order, when you're setting up your nested for loops, typically the outer loop is for rows, and the inner loop is for the column. So I'm going to say for, and I'm just going to call this int, I'll call it row for now. We're going to start at row 0, meaning we're going to start with this row with the 1, 2, 3 values, and we're going to go as long as row is, I can do this, row is less than the to show dot length, length. So again, when I call dot length on, for example, grid 2, it's going to give me the length of this is 1, 2, 3, right? So I'm looking at it big picture. The dot length of grid 2 is 3 elements, and those elements inside of it are actually arrays, right? So it contains 3 things, and they're all arrays, and each of those represents the rows. And then I'm going to say row plus plus. Okay, so now we're completed with our row setup. So now we're going to go ahead and set up our, oops, let me close that while I'm here. And now let's go ahead and set up for our column. So we'll say for int column is also going to start at 0. And we're going to say column has to be less than. Now notice the difference here. To show. Now if I do dot length on that, that's going to give me the fact that there are 3 rows. It could very well be that I actually have inside of there, I'll just put an extra 1 at the end of each of these. It could very well be that I have, actually that's nice, I'll leave that there. It could be that I have a different number of columns. So you can see I've got 1, 2, 3 rows, but inside of that, the columns, there's 1, 2, 3, 4 columns, right? So it would be a 1, and below that's a 4, below that's a 7, and in the last column it's a 1, a 1, and a 1. So I can't just do to show dot length. What I do is I say to show, get the very first one. So what I did is I just grabbed this array, and I say, what's the length of that? Dot length. And because my my arrays are not ragged, right? Every single one of those rows is going to contain 4 elements. So I don't have to worry about the fact that, oh, what if this one had 4 and this one only had 2 and this one only had 1? They're all going to have 4. Otherwise, that could be interesting. So they're not going to be ragged arrays. And then I'm going to say column plus plus. So we're set up now, and we've got a space right here where we are inside of our nested for loop. And what we want to do right now is we want to go ahead and print the values. And for grid 2, it's going to be the values 1, 2, 3, 1. Right, so inside of here, first, while row is 0, we're talking about this, we're going to be looking at the column first 0, and then 1, and then 2, and then 3. You can see there are 4 columns there. They're numbered 0 through 3. And that's why we are doing the less than that. So let's go ahead and just print system.out.print line pr print line. And we'll go ahead and print to show. And we're going to say, give me the value that is in row, right? So when row is 0, it's going to be row 0, and then column. So at a certain point in this loop, right, row will be 0 and column will be 0. It will be printing the value 1. While row is held at 0 and column updates to 1, it'll print the 2. When row is still at 0 and this is at 2, 0, 1, 2, it'll print out the value 3. So that's what's happening there. In addition to that, just to make it look a little bit better, I'm going to ask it to do a little escape sequence here. So I'm going to do escape sequence T, which is a tab character, so it'll just kick it over a little bit so we can see it better. Let's go ahead and close that. Now, I made a mistake. I do not want to do print line. I just want to do a print. So I want this row to stay on the same row. So it's going to print a 1, 2, 3, 1. Now, once that inner for loop is finished and we're getting ready to begin to update to the outer loop, I want to ask it to do one more print. And I don't need it to print any characters. I just wanted to do a print line so that it jumps down visually to what's going to be the next row. So if this is correct, what we should see happen in the case of the first one, we should see 3 rows that they're all zeros, right? Because this one was initialized, it's just the default values for these ints. So these are all going to be 0 values. So I should see 3 rows, 3 columns, all of them zeros. And for grid 2, we should see something different. So to test this, let's go ahead and ask this to print both of them. So I'm going to call the show grid method that we just wrote. Show grid requires a grid to be passed to it, a 2D array rather. So our 2D array that we're going to send first, we'll send grid 1. And then I'm going to ask it to do a, oops, let's not forget the semicolon, otherwise known as the dot comma. Oops, G-R-G. I spelled this one GERD, which is G-R-I. There we go, grid 1. Show grid 1. I want to do a print line in between these so that I can see a little bit of space between this grid and the next one. Let me copy P-R-I-N-T print line. And then I just copied this. Let me paste that and ask it now to go ahead and call show grid for grid number 2. So if we're successful here, we should see the first grid, 3 rows, 3 columns, all with zeros, and then we should see the second grid. So I'm going to come over here and ask it to compile this. I'm going to call the main method, and we get the following. Let's take a look at this. So looking at it, with our code back here, you can see, yeah, we got 3 rows, 3 columns, all 0. So 0, 0, 0. Yep. And then the next one, our first row is a 1, 2, 3, 1. Next row is a 4, 5, 6, 1. And the last row is 6, 8, 9, and 1. Perfect. And again, we could modify this. I could come in here and I could take some of these values out. So now this is going to be a square array, right? 3 rows, 3 columns. I could just come down here and ask it to compile that and to run that. And we can see, yeah, this is doing exactly what we would like for it to do. Right, we're going to move on and do a little bit more with this. So, like we were saying, like I said, AP Computer Science, the course typically looks at things as row major two-dimensional arrays. This picture class, right? There's a method in the picture class called getPixels. GetPixels grabs a one-dimensional array of a bunch of pixel objects, and it basically uses that one-dimensional array to wrap around all those pixels. And I kind of want to emulate that just so you can kind of see what that looks like. So I want us to create another array, another two-dimensional array, but I want us to do it from a one-dimensional array. So let's say int this. So this is just an int array, and I'm going to call this data, and this is going to equal just a standard one-dimensional array. And we're just going to put the values 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And actually, you know, that's too predictable. We've already seen that up above. Let's just do this. We'll do 0, 1, 2. We'll go 4, 4, 6, 5, 1. All right. Now I want to check and make sure I've got 1, 2, 3, 4, 5, 6, 7, 8 values. 1, 2, 3, 4, 5, 6, 7, 8 values. You know, let's put a ninth value in there. I'll just say it will end with an 8. Okay, so I've got this one-dimensional array. Now, what I want it to do is I want to call a method that will take that one-dimensional array, and it will create a two-dimensional array from it. Now, when I do that, I need to tell it how many rows and how many columns I want, because there's a lot of ways I could do this. For example, if I said I wanted 4 rows with 2 columns, that means that each row would just have 2 elements in it. So it would be a 0, 1, and then a 2, 4, and then the 4, 6, and then the 5, 1, and it would stop. Or I could say 3 rows with 3 columns. That first row would be 0, 1, 2, 4, 4, 6, and then 5, 1, 8. So we definitely are going to have to create this method below, but let's say we're going to get a new two-dimensional array, and we'll call this one grid3. And grid3 is going to use our method that we're going to write below called a 2D array, or we'll just call it 2D. I'm feeling like R2D2. I don't know. 2D, and 2D is going to need the following 3 things. First of all, we're going to pass it a two-dimensional array, and we're going to say that we want it to create a two-dimensional array based on, we'll say 3 rows and 3 columns. That's going to be important down there because I'll get different arrays depending on the values that we send to it. Okay, so check this out, right? It's going to require 3 things. The first thing is going to be an array of ints, and then an integer, and then an integer. My intent is that this integer is the number of rows, and this int is the number of columns. So let's scroll down here and create this method by writing its method header. So it's obviously going to be I guess it doesn't have to be public, but public, actually probably this should be a private method. Public static int, it's going to return a two-dimensional array, right? And I know that because, well, that's what I'm intending to make. This thing is going to make a two-dimensional array, and then that's what you can see. Then this is going to be assigned the two-dimensional array it creates. So the return type for this method has to be a two-dimensional array because that's what grid3 is going to require. So the return type is a two-dimensional array, and it's going to be called the number 2 and D, and it's going to require 3 arguments. The first is the one-dimensional array that I'm just going to call data. The other thing it's going to need is an int that I'm going to say represents the number of rows, and another int that represents the number of columns. And we are now ready to write this method. So obviously we've got a problem right here. This needs to return something. The thing that needs to return is a two-dimensional array. Before I get into this, I'm going to say, well, let's make the two-dimensional array. And I'm going to call it result, because that's what I'm doing. I'm making it. I'm going to return it as my result. It's going to equal a new array of ints that will have this many rows and this many columns. And again, those are just the things that were passed as parameters. So we have a two-dimensional array called results that will have R rows and C columns. And now down here, I'm just going to say, well, let's go ahead and just return that. Return result. So now you can see my compiler is not going to holler at me anymore, and I can kind of look at things. In fact, I could run this right now, and if I asked it to print that, it would print out something with 3 rows, 3 columns, but everything would be a 0. Nothing would be initialized yet. So what we're going to do is we're going to go ahead and read data from this array called data, and we're going to use that to put things in the rows and columns. So you can see up here how we used nested for loops to access values in the array. We're going to follow this structure and create a nested for loop to put values into the array. And the values that we put into the array are going to come from this array called data. Now I need to keep track of where I'm at in this data array. So I'm going to create an integer called pointer. And I'm going to set it equal to 0 to start with. So this is going to keep access to what number I'm placing next in the array. And I just have to remember to keep updating that in the context of my for loop. So let's go ahead and create our nested for loop again. So for int row equals R. Keep going as long as row is, I could actually say less than R. Oh no, I want row to start at 0. Int row starts at 0. I can keep going as long as row is less than R, right? That would work because I can see that, yeah, that was the parameter. It landed here. That's the number of rows I need. But I can also say, and this is probably better practice, is just say it's going to keep going as long as it's less than result.length. And then it models what we did up above too. And then row plus plus. Okay, we are inside of our for loop. Now let's get inside of that for loop and make another for loop. So for int column equals 0. We're going to keep going as long as column is less than result. I could say less than C, that would work, but I'm going to do this. I'm going to say result, and then I'm going to just grab the 0th row from that array, right? I'm just going to grab the one in the first spot there, dot length of that, and then I will say column plus plus, and I am now inside of my nested for loop. So what we do at this point is we need to place values into our result. So if you look at it, we're going to say result, R-E-S-U-L-T, at spot row and column, and that is going to equal the value that is in data at pointer. Now we'll talk about this, but let me do one more thing before we talk about it. I'm going to say pointer and then plus plus. So pointer is it starts at 0, and every single time I grab a value out of this array called data, I update it to the next spot. So if you look at this, when we first come into this nested for loop, I'm at row 0 and column 0, and what it says is result at row 0, column 0 is going to equal the very first value in pointer, the value at spot 0. Then I update this to the next spot, and now it says row 0, column 1, right? Because column is the one that it gets incremented inside of this inner loop. Row 0, column 1 is going to read off that next value, the one at spot 1. And then it's going to be row 0, column 2, etc. Once I've filled all the column values in, right, this jumps around. Row gets incremented to 1, and now I'm at row 1, column 0, right? Row 1, column 0. Then I'm at row 1, column 1, and row 1, column 2, etc. And I keep just reading those values. So because of that, you can see that the array is going to have the very first row will be 0, 1, 2. The next row will be 4, 4, 6, and then 5, 1, and 8. And we did, let's see, we did complete that loop. We completed our nested for loop. And after I've gone through and I've created all those values, oops, let me delete this. Right, once we've placed all those values in from this data, right, then we're returning that array. So take a look at this, what we're doing here again. We're creating a two-dimensional array called result that has exactly R rows and C columns. And we're given a one-dimensional array called data. We've initialized this counter called pointer at 0. And what we're doing is we're reading values from data and we're placing them in the correct row column based on this nested for loop structure. Once we complete visiting all of our rows and all of our column spots, then we just return that array to results. So let's come up here and ask it to print that out so we can check and see what's going on here. So we're going to say, oops, let's do another, you know what, I'm going to grab just both of these. Whoops, not all three of them, just these two. Copy those. I'll paste those here. So I'm going to say, let's go to systemout.println. That's just going to go to the next new line, and then I want to ask it to print grid 3. So now we should see all three of those grids displayed. I can bring, whoops, let me bring this over a little bit more. Good. And let's go ahead and bring up this window. We will go ahead and compile this, and we will go ahead and run the main method again. And there we go. And when we come back and look at it, you can see, yes, 0, 1, 2, 4, 4, 6, 5, 1, 8. Fabulous. Let's talk about that some more. But as I do, it just occurred to me, it's kind of goofy that these methods are visible. I don't intend anyone to ever call those. So what I'm deciding to do is go back down, and I want to make both of these private methods, PRIVATE, and I'm going to make this one private also, PRIVATE. So when I look at this now, right, I'll compile this again. And you can see that now the outside world, oops, is completely unaware of those methods. The only thing that shows up is the main method. That's something that I can call. So I can call this method, but I have no access to the two private methods. But the good news is even though they're private, everything still works, right? It has access to its own methods. One more thing I want to show you before we leave this fabulous lecture today. I want to show you what happens if I was to change the rows and columns here. So for example, I could change this to the number 2. That would mean I'd have 2 rows. And in each one of those rows, I could say there's going to be 4 columns. So what's going to happen is this, in this first row, right, all the data is going to be read 0, 1, 2, and 4. So row 0 will be 0, 1, 2, 4, and then row 1 will be 5, 2, or 4, 6, 5, and then 1. And there's going to be an extra value here, and that's going to be completely fine. So this is in row major order. So all of the data for the first row is contained in this data list, and then all the data for the next row follows that. And then there's an extra value here. So just real quickly, let's go ahead and take a look at how that changes things. Fabulous. So you can see that first row contains those. And you can do this for any number of rows and columns as long as you have enough data. So for example, if I was going to say, well, let's do 2 rows and make it 5 data points each, perhaps you see the problem I'm going to have. Perhaps you do. Perhaps you don't see the problem I'm going to have. But that needs 2 times 5 is 10 elements. And I don't have 10 elements, do I, class? So if I come back up here and I say, let's go ahead and compile that and run it again, I get this wah, wah, wah. I have an index out of bounds error. What's happened is I'm just updating pointer plus plus, assuming I'm going to have enough data. And you can see I didn't have enough data. I ran out of numbers while trying to fill up that last row. So that exception occurred. So if I want to fix that, I could come down here and I could do a little bit of error checking. Basically, row times column. So if I multiplied R times C, that should equal the dot length of data. So I could do a little error checking. And I could say, hey, if row times C is not equal to this, just return the blank array with all the zeros, because, or because we're just demonstrating things here and I'm not really being rigorous in my error checking and trying to prevent errors. I could just put in a few more datas. I could put in a 5, 6, 7, 7, 8, 1. So now I have tons of extra data. I could compile this and I could run it again. And this time you can see I do not have that problem. I definitely have enough data, and you can see that, yeah, that first row contains the 0, 1, 2, 4, 4, right to there. That's the first row. And then the next row starts at 6, and I've got the 6, 5, 1, 8, 5. And actually, I have enough. No, I don't have enough data for another one, do I? But I can also say, oh, let's say that I want to have 4 rows and 1 column. Okay, that's only going to be 4 values. It's just going to be these first values. But what I should see is a 0, and then below that a 1, and then below that a 2, and then below that a 4. And if I compile, and if I run that, there it is, 0, 1, 2, and 4. Well, class, it's been 31 minutes that I've been droning on with this lecture here, so that's more than enough for today. I'm going to try to keep these around 30 minutes each day. So you're going to find this video linked in an assignment. The assignment's also going to contain some items for Runestone. It's really important to me that you do watch these videos before you jump into Runestone. Not that my ego can't handle you ignoring me, but I do think that I find kind of talking through these things helps a little bit, and this is new information for most of us. So I hope you have a great day. Perhaps I'll see some of you during office hours today. Office hours are going to be at 1:15 every day, 1:15 to 2:15, I believe. Or is that wrong? You know what? It says it on Teams. What did I say? If I go to Teams and I go to, I'll just go to period 4. Oh, Russell, you're still in the wrong team. I'm sorry. I said, yeah, 1:15 to 2:15. So I will, at this conversation right here, there's the general conversation for the class, I will post an open session in Teams. You can come in and ask questions. Anything you've got going on either in Runestone or about today's lecture, I'd be happy to talk with you. All right, class, have a great afternoon. Take care.